with you. Now, you must first, normally you go for the length first. That means how many cm they give to you. Okay, so I will draw a line using my ruler, BC over here. Okay, and it should be 6 centimeters. You have to measure to ensure that it's 6 cm, all right? Next, after you draw this already, you can go for either one. Okay, I'll go for angle ABC first. It is how many degrees? 22, right? So take your protractor, put it over here, and measure and mark out 22 degrees. It's somewhere here. This is about 22 degrees. Mark it out first. After you mark it out, use a ruler, okay, to cut through the marking and label this as 22 degrees. But don't label point A first. You don't know where it's point A yet. You don't know how long this line will go. It can go on forever. It's 22 degrees, right? Next, take again a ruler, a protractor, to measure 95 degrees. Put a marking. Measure it, put a marking. Can use a ruler to extend the line. Okay, you did it correctly. Your answer should be something like that. And you can finally label the point here to be A. Only label A after you find the crisscross, the cross of the two lines. Then you can label down point A. Okay? Okay, don't worry too much about this kind of questions. Be as accurate as you can, because in the answer sheet will mark it for you, right? There's a plus minus. That means if you're off by 1 or 2 cm, can be not 2 cm, but off by 1 cm, should still be okay. If it's very off by 2.5 cm, confirm wrong already. So just be as accurate as you can. Okay, the angle measurement also. All right. So this will be the rough shape for this question. Okay, Ken? Shall we move on to the last 2 questions? Normally paper 1, paper 2, there will be one graph plotting, but it's not paper 1 in this case, right? It's paper 2 that has the graph plotting. Because paper 1, they give you a graph already. Okay, find the gradient of AB. Let me recap the gradient formula with you. Gradient is represented by the alphabet M. Okay, M will be equals to Y2 minus Y1 over X2 minus X1. For the gradient formula, some schools, they will teach you as rise over run. Meaning, you got a graph, it will be this. This is the rise. This is the run. Basically, the difference in the Y divided by the difference in the X. So you are allowed to pick any 2 points on the graph to find your Y2 and your Y1 values. But be smart. Don't go and pick the decimal one. Like for example, here, don't pick here. Very, very, very confusing. Try to pick whole numbers if you can. For example, picking here, this point is 6, 5. X first, then Y. X comes first before Y in the coordinate. Okay? And the 5 comes from here. This side. This one is a 5. Okay, so this point will be 6, 5. And I'll pick another point over here as well. I can pick this point over here. This point will be -2, -1. Okay, -2, here will be -1. So those will be my triangle. Gradient triangle will be like this. Okay. So maybe I can call this my x1, y1. Sorry, x2, y2. And I can call this my x1, y1. That doesn't matter, as long as you keep the order. Doesn't matter which is which. Okay, so the working here, y1 is 5. So 5 minus -1 over 6 minus -2. And you will get the gradient to be 6/8, which is 3/4. Okay, of course, we also accept 0.75. Okay, so that's how you find gradient. All right. Okay, I'll give you a while to copy down first if you need. you can almost guarantee the gradient will be tested for your exam. Okay, so please remember the formula. Rise over run, or y2 minus y1 over x2 minus x1. Okay. Now, the equation of a straight line is y equals to, if you can still recall, mx plus c. Now, we already have the m. The m is the gradient, right? So I can put the m in first. This will be 3/4 x plus c. How do I find c? And what is c actually? C is your y-intercept, where the graph cuts the y-axis. Okay, so in this case, if you look very carefully in your graph, the y-intercept is 1, right? Over here. Oh, sorry, hold on, wait. My bad. It's not the line, it's not AD, it's BC, right? Okay, my bad. Shouldn't be. Because BC is not a diagonal line, it's a vertical line, right? Okay, let me erase this, so I see wrongly. It should be BC. BC is where? BC is the vertical line, right? It's the one over here in purple. Okay, so BC, right, is simply just x equals to 6. Okay, how do you get a 6 from? At the bottom here. So just to recap with you, right, all vertical lines, they are x lines. What do I mean by that? For example, this is x equals to 1, x equals to maybe 3, x equals to -2, so on and so forth. All horizontal lines, right, they are y lines. Y equals to 4 maybe, y equals to -1. Okay, so over here, BC is a vertical line and the number below is 6. So the equation of BC will be x equals to 6. Please don't put 6. If you just put 6, it's wrong because it's not an equation. You have to put x equals to in front of it. Okay. To find the area of triangle ABC, we can use half times base times height. I will turn my paper around so you can see more clearly how to find the area of this triangle here. Okay, ABC, triangle ABC, right? Okay, if you look very carefully at the diagram, the base of the triangle, right, is from here to here. So if you go and count, this is 2.5 units. Okay, the height of the triangle is from here to here. If you go and count this will be 4 units. Because I have 6 here and 2 here, right? -2 here. Okay, sorry, more than that. It will be 8 units in total. Okay, because 2, 4, 6, 8. Okay, below is 1 and 1 plus 0.5. 2 plus 0.5. Okay, so once you have these two correct already, you can apply your formula to use half times base times height. Let me flip it back. Okay, so half times base times height will be half times 2.5, which is the base, times the height, which is 8. And you should get... Okay, wait, this should be 3, not 2.5, because the gap there is 1. Okay, so you need to be very careful. So my bad, so it should be 3. So let me write it out properly. Here, it should be 1 unit. So total here will be 3 units. Okay, so half times 8 times 3 will be equals to 12 units squared. Okay, we use units because we don't know whether it's cm or meters. It never tell us. If it never tell you, use units instead. All right. So the answer will be 12 units squared for this question. Okay. So be very careful to look for the base and the height accurately. All right. Okay, we got one last question to go. We might be able to end early. All right. So this will be the last question. But before we do the last question, I want to first unpack for you all the important terms first. Copy this down. It's quite important. Integers, what are they? They are whole numbers. Okay, whole numbers. These are integers. Irrational numbers. These are numbers that cannot become or be expressed as fractions. And perfect squares, what are they? Perfect squares are numbers where when you square root them, you get a whole number. So 4 is a perfect square. 25 is a perfect square. Because square root 4, you get a whole number. Square root 25, you get a whole number. Is 2 a perfect square? Yes or no? No, right? Because square root 2 gives you about 1.41 something. This is not a perfect square. You don't get a whole number. Okay? So, which one of these are integers? You have 0, 36, any more? Any more? Okay, it's a tricky one. Huh? There's one more. Anyone can spot it. Okay? If you go and press your calculator, this will give you a value of 4. So actually, it's a trick question. This is also an integer because the cube root of 64 is a whole number. 4 times 4 times 4 is 64. Okay? Irrational numbers. When you think of irrational, you think of pi. Pi is always irrational. So you have pi over here. Any more? Square root 3 is also irrational. Most square roots are irrational, but be careful what? Square root 4, for example, is it rational or irrational? It is rational, right? Because this is 2. It can be expressed as a fraction. So this is rational. Okay, but most square roots like square root 3, square root 2, square root 5, square root 7, all these are actually irrational numbers because they cannot become fractions. Perfect squares. 36, right? Okay, 36. I need more. 0, right? Because square root 36 is 6. Square root 0 also whole number. I need more. Okay, sorry, I'll ask you, I need more. There's one more actually. There is also a perfect square. Okay, let me think for a bit. Okay, the one more perfect square is the same culprit as part 1. It is cube root 64. Why? Because this will be 4, right? And square root of 4 is equals to 2. So this is also a perfect square. Okay? And the last one, you can use a calculator. Simply put all of them into decimals and you will be able to rearrange them properly. The first one that we should have over here in descending order. Descending means decreasing, right? From big to small. Big to small. Okay? So we have 36. We have cube root 64. This is 4. Pi, because pi is around 3.14. We have square root 3. Because this is about 1.773 something. We have 0, of course. And we have negative 1 over 7. Okay. Did I miss out any numbers? I think I missed out one number. 3/5, sorry. There's a 3/5 also. 3/5 is 0.6. So it should be in front of 0. Okay. Then you have a 0 over here. And there is a negative 1 over 7 here. Okay. Negative numbers will always be in the back because they are much smaller than positive numbers. All right. Okay, please copy this down. After you copy down, I will say a few final exam tips before we close the session for today. Okay, 1 minute, copy it down. Then we'll end off with some exam tips.